Okay, so one more time, radical review. Even though it's titled review here, there are some new concepts towards the end. All right. Are we ready? Okay. Square root of 24. I'm going to have you try that from memory. Breakdown is the one hint I'll get you. Break down to its prime factors. Go ahead and do that now. Do you guys remember how to do it? Let's at least break down. What did you guys break 24 down into?
8 and 3.
8 and 3 or 6 and 4? Does it matter which one you use?
No.
No, I'm going to use 8 and 3 since I heard it first. And 8 breaks down into 4 and 2, and 2 is prime, and 4 breaks down into
2 and 2.
All right, and how many 2s do I have?
3.
3, and how many 3s?
3. 1.
1. And then I put a square root around it. And do you guys remember what comes out? The pairs, right? Pairs come out. For numbers, yes, numbers do. Now these are paired. So this pair here comes out. Are these two pairs?
No.
Do they match? No. Can I tag this 2 on with this pair here? No, only 2 at a time, not 3. That's a cube root or 4th root or 5th root, which we'll deal with another time. All right, so what is the only thing coming out? Does this come out as 4 or does this come out as 2? 2. Why? Because what is 2 times 2?
4.
It is 4, but the square root of 4 is 2. So this comes out as 2. So when I write my answer, the 2's on the outside, this 2 right here, root, and what do I do with the 2 times 3? 6. Inside, multiply. 2 root 6 is your answer. Anybody get that or something close? Good. All right, number 2. Negative square root 243.
Negative.
Oh, yeah, negative. Okay, how is that going to affect your answer or change your answer at all?
It won't.
It's okay. I heard 2 things. You can't square root a negative, and I heard it's not going to mess us up because the negative's on the outside. All right, so that is correct. So if this was negative on the outside, this final answer would be negative 2 root 6. So break it up and just tag a negative in the front. All right, so go ahead and break it up. Do you guys know the shortcut to know if a number is divisible by 3? Does anybody know that shortcut?
No.
First off, we know it's not divisible by 2. Why not? It's not even. It's not a number. Yes, you can plug in your calculator, but if you don't have a calculator, or if you're trying to go quick, add the numbers up. What's 2 plus 4 plus 3? 9. Is 9 divisible by 3? Then 243 is divisible by 3. It works every time. If the sum of your numbers adds up to a number that's divisible by 3, then your original number is divisible by 3. That works with 3 and 9. It doesn't work with other numbers, but it does work for 3 and 9. All right. Oh, what does 2 plus 4 plus 3 add up to again? 9. Okay, so that means not only is it divisible by 3, it's also divisible by 9. All right, so try it and see what you get. Anybody tell me at least 2 numbers you used to start with?
81 and 3.
81 and 3, and did I hear anybody say 9 and 27? All right, and that's perfectly fine. I'm going to continue with 3 and 81. 81 is that 9 and 9?
Yeah. Oh.
And each 9 breaks down to
3.
All right, how many 3s?
1.
1, 2, 3. Is there 5? Is that enough for all of them to come out? Or will 1 be left behind?
1 will be left.
Right, because it's odd. You agree? If you're if you're taking out pairs, yeah, 1 will be left behind. Okay, so this comes out, and this one comes out. Now, again, I'm going to cover everything. What's 3 times 3?
9.
But the square root of 9 is 3. So when this comes out, it comes out as just 3. This is also 9, but the square root of 9 is 3. So I'm left with two sets of 3's that come out. The first set, the second set. What's 3 times 3?
9.
9, but don't forget the negative. So negative 9 root, what stayed inside? 3. Got it? Okay. Now, because this is new, this is how I will continue doing it. But for those of you that like grasp things fairly quickly and like, oh, I got it, and show me shortcuts and stuff, I'm going to backtrack here. Do you see where we have 3 times 81? And 81 was 9 times 9? Yes? You do not have to break up further. If you can see, hey, this is 3 times 9 times 9, and this is going to come out as a pair, you don't have to break up all the way down. 9 times 9 is 81. What's the square root of 81? 9. So what's coming out?
9.
And what's staying in?
3.
And is that what happened here? Huh? Anybody like that shortcut? Maybe? Again, you don't have to use it. I'm going to continue breaking it all the way down because it is fairly new for us. But if you get the hang of it and you're like, oh, I have a pair here, then don't break it down. Just take that pair out. For example, if this pair was 8 times 8, do you have to break each 8 down? No. Take it out. It's just going to be 8, or in this case, 9. Does that make sense? If you don't like it, then this is the way we're going to continue doing it here. All right. Number 3. 3 root 128. How does this one change a little? There's a number in the front, the coefficient there. Does everybody see it? Yeah? Okay. Any thoughts on what we're going to do with that number? What did we do with the negative here that was in the front? We multiplied it at the end. Do you agree?
Yeah.
Think of that as a negative 1. What's negative 1 times 9?
9.
Negative 9? All right. So yes, thank you. So think of this as a negative 1 times this. Same thing here. This is going to be 3 times whatever this breaks up to once we pull things out. All right. Because it's even, you can break it up by 2. You can try something bigger if you'd like. Once anybody have 2 numbers, give them to me.
Put it in the calculator to do it.
Don't worry about the 3. You're just going to break up the 128 as you would the 24 or the 243.
I know, but how do you do that?
Just 128 divide by 2, since it's even. Which is what? 2 and 64. I'm going to circle the 2. Ignore the 3 completely for now. 64, go ahead and break up in 2. What do you get? 8 times 8. Did anybody use 32 times 2? And that's perfectly fine. If you did use 8 times 8, could you stop here and say, oh, there's a pair?
Yeah.
Those of you that have the hang of this, what would this come out to be? Ignore the 3. 8 root 2. And then you do 8 times 3. All right, so there's a shortcut. I'm going to keep breaking up since I said I would. What does 8 break? Each 8 breaks up into 4 and 2 and 4. Prime, and 4 is 2 and 2. Okay, so how many 2's do I have?
7.
7. So is everything coming out, or will there be one left behind? 1, 2, 3, 4, 5, 6, 7. Don't forget the 3 on the outside. All right, let's circle all of our pairs. There's one set, and when this set comes out, it comes out as just a 2. This set comes out as just a 2, and this set comes out as just a 2. Ignoring the 3 in the front, what's 2 times 2 times 2? 2 times 2 is 4. 4 times 2 is 8 root 2. Is that what we said for those of you that use the shortcut up here? Hey, there's a pair. 8 comes out, 2's left in, 8 root 2. Do you see that? All right. Now, if you put this on a test, why would I mark it wrong? I didn't use the what?
3.
The 3. It's this times 3. What's 3 times 8? 24. So 24 root 2.
Wait, I have a question.
Yes.
Wait, 2 times 2 times 2 is 2 times 2 is 4. Oh, what the heck?
Did you put 6?
Yeah.
Yeah, I know. It's you're thinking fast. 2 plus 2 plus 2. Yeah. Yeah, you weren't the only one. I heard a few 6s out there as people were giving me answers. Okay, are we good? Got it? All right, number 4, 12, the square root of, 12x squared.
Oh.
Oh no. And we're going to assume here that our variables are positive. Our variables are always positive. All right. What's different here?
A variable.
The variable. Ignore it for now and break up the 12 just like you usually would. And that one's an easy number to break up. All right, what does 12 break up into? 6 and 2, or did anybody use 3 and 4? All right, same. We should end up with the same answer. 6 is 2 and 3, so I have 2, 2, and a 3. Those of you that use 3 and 4, same set of numbers? All right, I'm going to expand the x squared. X squared means how many x's? 2. And then I'm going to square root. And you take out your variables in pairs just like you do the numbers. All right, so let's circle. Do I have any common pairs here with the numbers? 2, when it comes out, does it come out as 4 or just 2? 2. How about the variables? Do I have enough to circle a pair? And when it comes out as just what? X. So 2 times x is 2x. Root, what's left over? The 3. Not that hard, do you agree? It looks different, it looks complicated, but it actually is pretty easy. You treat them the same way you would the numbers. All right, I'm going to give you this next one to try on your own. Number 5, square root of 125x to the 5th. Yes?
Is this review like reviewing everything that we learned?
No, this, we've done radicals back when we did the unit, the lesson where I think it was like a mid-segment theorem. Do you remember that? Let's see if I can find the notes. We did it when we were doing the distance formula, and we had to simplify to show that one distance was double the other distance. Do you guys remember that? Yeah, that's when we first learned how to work with radicals. I can't find it in the notebook, but we have it in there somewhere, where we doubled. And we learned how to simplify radicals then. I'll have to look for it and show it to you, but we've seen the radicals, so it's just review of the radicals, not review of everything. All right, you're breaking up. Can anybody give me at least the first set of numbers you used for 125? 25 and 5. Okay, keep going.
5.
All right, so how many 5s?
3.
And how many x's? 1, 2, 3, 4, 5. Do I have enough 5s where they're all going to come out, or will there be one left behind?
One left.
What about x's?
One left.
How can you tell just by seeing x to the 5th knowing there'll be one left? Because 5 is odd, right? All right, so let's circle the pairs. I have this set here is coming out as 25 or coming out as 5? 5, because 5 times 5 is 25, but the square root of 25 is 5. All right, that 5 gets left behind. This set comes out as just x. Another set comes out, yes or no?
Yeah.
X, and what about the third one? It gets left behind, or the last x. All right, so 5 times x is 5x or 5x squared. All right, so when you're multiplying variables, you add the exponents. 1 plus 1 is 2. 5x squared, square root, what's left inside?
5x.
5x. Beautiful. All right, make sense? All right, I need questions if there are any questions before we move on. We're going to be dealing with a whole lot of these type of radical problems the rest of this unit. It is. Math is always fun, though. True. All right. What?
Oh, you heard that?
Uh-huh.
Sorry.
You got a haircut? What did you say?
He said, you heard that? Not, you got a haircut. All right, number 6. Root 12 times root 24.
Oh, no.
Oh, no. All right, we have our calculators, our handy dandy calculator, so that's a good thing. All right, now, radicals and multiplication is allowed. You can rewrite it like this. You cannot do that with addition or subtraction, but you can do it with multiplication and division. You're allowed to write it under one radical. All right, any thoughts? This is a multiplication sign. Any thoughts on what to do next? Yes. Okay, so do you guys have your calculators out? Can you plug it in? He said multiply them together. 12 times 24. 288. All right, now, what do we do next? Break it down. Now, when we break it down, what numbers do I use? Could we use 12 and 24 again? Yes or no? Now, if you wanted to, could you use 2 since 288 is even? Yes? Probably even try a 4. 4 would probably work. 6? All right, before you go further, pause really, 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 really quick. Okay, this is the way most kids do it, and it's perfectly fine. But once you multiply and get 288, do you go right back to breaking it up to what you started with? Yeah. If you wanted to, could you break up the 12 and 24 right from the get-go?
Yes.
Yeah, yes, you can. There's nothing wrong with it. Both ways work because you have calculators. It's pretty easy either way. But I'm going to break it up with the 288. All right, so 12 and 24, and keep going from there. Did anybody break it up into something other than 12 and 24? We all use 12 and 24? All right. All right, once you break everything up, how many 2s do you have?
5.
5. 1, 2, 3, 4, 5. Let's see. 1, 2, 3, 4, 5. All right, how many 3s?
2.
And are we ready to take things out? Is everything coming out, or will there be some left over? Some left over. If, just by the way, if everything comes out, there's no radical left in your answer. Just a reminder, if everything comes out, the radical's gone. Bless you. All right, this first set comes out as just a 2. The next set also comes out as a 2. That 2's left behind, and this comes out as a 3. Again, because 3 times 3 is 9, and the square root of 9 is 3. So I have 2 times 2, which is
4.
times 3, which is, so 12 root 2. Anybody get that on their own before I did? I think you had it already done. Good job. All right. Number 7. 2 root 12 times root 75. No, thank you. All right. Now, when you multiply your coefficients together as well. So I'm going to put a 1 here, even though it's not there. Do we know there's a 1 there?
Yeah.
What's this coefficient 2 times this coefficient of 1? 2 times 1 is 2. Root, now you can leave them separate, 12 times 75, or multiply. I'm going to have you multiply it on this one. What is it?
900.
Now there's a reason. Because 900, I'm going to cover the zeros. What's the square root of 9?
3.
3. So what do you think we should use for 900?
3.
3. Instead of 3, let's try a 30. Can you guys check if 30 times 30 is 900? You can probably do that in your head.
It is.
Is it? All right. I'm going to stop. Bless you. And I'm not going to break up. You can. Don't get me wrong. You're more than welcome to if you want to. But why is it okay here to stop at 30 times 30?
There.
It's a pair. You're wasting time if you continue to break up. It's not wrong. You're just taking more time than needed. Got it? So this comes out, this pair here comes out as what?
30.
This comes out as just a 30, and I'm left with 30 times what? Times the 2 that's in the front. So what is that? What's 2 times 30?
Root 2, 60.
60. And is anything left in the radical, or everything came out?
Everything came out.
And what happens when everything comes out? What happens to the radical? It goes away. It's gone. So 60 is your answer. Did anybody break up the 12 and 75 separate? Did you get the same answer?
Wait, but I got 30.
Okay. 30 and then times the 2 in the front.
Oh, yeah.
All right. Okay, so I'm going to do it over here. So you break up the 12. And before I break up, did anybody break up each 30? Like 15 and 2, 15 and 2, and go from there. All right, we should end up in the same place at the end. So I'm going to do it. 12 is what? 4 and 3. 4 is 75 is 5 and actually I'm going to use 25. 25 and what? 25 and 3, and 25 is 5 and 5. All right, square root, and how many 2's? 2 2's. How many 3's?
2.
And how many 5's? All right, so if you broke up these two 30's, you should have 2 2, 3 3, 5 5. Or if you broke up the 12 and the 75, again, 2 2, 3 3, 5 5. Can you see that everything's a pair and everything's coming out? This comes out as what? 2. This comes out as 3, and this comes out as 5. What's 2 times 3? 6 times 5 is that same 30 we got here a lot quicker. And then don't forget that 2's in the front, and 30 times 2 is 60. Got it? Anybody like this shortcut where you find a pair and you don't have to keep breaking up? It's a nice tool. It's a nice tool to have. It's not necessary, but it's nice because it saves you time. All right, number 8. Any questions before I move on? Okay, so this next piece is another piece that will continue to come up throughout not only this unit, but throughout the year. And kids struggle, so you want to make sure you are paying attention. 3 root 5 quantity squared. What is this square telling us? To do what to the base? Multiply it by 2 or multiply it by itself one more time, like you said. All right, he said write it again. So like this. 3 root 5 times 3 root 5. Do you guys see how that worked? Okay. Now, just like we did before, you multiply the coefficients. What's 3 times 3? 9. What's 5 times 5?
25.
And what's the square root of 25? 5. So I have 9 times 5, which is?
45.
45 is the answer. All right, I'm going to talk about, this is easy. That way was not hard, but I want to talk about one little step to save that'll help you when the numbers get bigger. Are you ready? Okay, so if you didn't write it, could you agree you could say, oh, square the 3 and square the square root of 5? What's 3 squared?
6. I mean 9.
9, is that what we have here? And then square root of 5, 5 squared is 25, so square root of 25, yes or no?
Yeah.
All right, now right here, 3 times 3 is 9. Do you guys agree that this is going to be a pair? And when the pair comes out, what is it going to come out as? 5. So you can skip this middle step, and 9 times 5 is 40. Now, right now you're thinking, well, that's not a hard step. It's not, but when the numbers get bigger, it's a nice tool to have. Let me show you what I mean. 2 root 53 quantity squared. Okay, let's assume you're doing this without a calculator, so don't touch your calculators on this one. All right, I'm going to do it the same way I did the last one. I'm going to write it twice. Okay, multiply the coefficients. What's 2 times 2? 4. Now, without a calculator, I would not want to waste my time multiplying 53 times 53. Do I have to? No, because what do I see here? There's a what? A pair. Do you see that? So what is this pair going to come out as? Just 53. So 4 times 53, that part you will have to do. 53, you can do that easily though without a calculator. I mean, you could use your calculator, but initially I said put your calculators aside. But you can use it now. So plug it in or do it by hand. What is it? 212. All right, so what I want you to get from this particular piece here is that when you have these radical pieces, quantity squared, multiply the coefficients. 2 times 2 is 4, 3 times 3 is 9. And the radicals, you do not have to multiply them because the pair is going to come out as just 5. The pair is going to come out as just 53. Do you see that? All right, questions here. All right, I know these notes are long, but we do have just a tad bit more to get through.
How many more?
A few. All right. Square root of 49 over 16. Big radical and a fraction inside. Yes. All right. Now, because I said earlier multiplication, division, you can rewrite them as 1 or rewrite them as 2. For example, you can rewrite it like this. You could do that with multiplication and division. You can put them together. You can separate them. What's the square root of 49? Without any breakup. What's the square root of 49? 7. Without any breaking factor tree, what's the square root of 16? Let's not forget, when we're faced with easy ones like square root of 16, square root of 64, don't do the factor tree. You should know them. So what's our final answer? 7 over 4. Leave it like that. You don't need a decimal. You don't need to change it to an improper fraction or mixed number. Leave it like this. All right. Any questions on how we got 7/4? Now, I will ask you this. Do you need to show me this middle step? No. If you can say, oh, square root of 49 is 7, square root of 16 is 4, 7/4, you're good. Got it? Mm-hmm. All right. Now, here is where it gets tricky. 1 over the square root of 5. All right, we're ready? Now, you're thinking, well, there's nothing to do. Square root of 5, 5 is prime, there's nothing that breaks up. I will tell you this. It is mathematically incorrect to leave the radical in the denominator. It's not allowed. So if you ever did a problem and you got all your work and you ended up with this and this is the answer you gave me, I would mark it wrong. Even if all of your work was correct. Why? Because the radical's not allowed where? In the denominator. So we do what's called rationalizing. You rationalize your denominator. This is new for us, so this is the new part. Are we ready? Okay, you multiply top and bottom by root 5. Just write it for now and I will explain. You multiply top and bottom by root 5. Everybody have it? Don't do any work, just write it down. Pencils down and you're listening. Okay, first off, what's root 5 over root 5 equivalent to? 1. And multiplying by 1 is what? 1 is the multiplicative identity. Do you remember that? When you multiply by 1, does it change your problem? Does it change the value? No, right? That's why it's called the multiplicative identity. It keeps the identity. So multiplying by 1, is it going to keep the value of 1 over root 5? Yes, it's going to look different, but it's going to keep its value. Does that make sense, first of all? All right, second, why root 5? Why not root 7 over root 7 or root 8 over root 8? Why do you think I chose root 5 over root 5? Because that's this number here. So if this was a root 7, would I choose root 7 over root 7? All right, and here's why, and it works out beautifully. What's 1 times root 5? 5. Root 5, right? Now there's a pair here. What is root 5 times root 5? 5. Good job. Now, could you say, oh, that's 25 and the square root of 25 is 5? Yes. Should you save the time and say, oh, there's a pair, it's just 5? All right, this is your answer. And why is this mathematically correct? Because there's no radical in the denominator. It's okay if it's in the numerator as long as it's not in the denominator. All right, I'm going to give you one to try on your own. 2 over root 7. Don't worry about anything that's not in a radical. For example, that 2 up there, pay no attention. Just ignore it for now. What do I multiply top and bottom by?
Root 7.
Root 7 over root 7. Why? Root 7 over root 7 is equivalent to 1, and 1 is the multiplicative identity. Do you guys remember that? We just said it. And why did we pick root 7? Because we want the denominator to have a pair. Do you see that? All right. Go ahead and continue. Can I write this as root 14? We can't because this is not an radical. If this was root 2 times root 7, yes, that would be root 14. But like this, it's just what? 2 root 7. Do you see that? Okay, I'm going to repeat it. I'm going to erase it right now, so don't write it. If it was like this, root 2 times root 7, could I write that as root 14? Yes. But since this 2 is not in a radical, I cannot multiply them together other than doing 2 times root 7. It's the best I can do. All right, here's a pair without using 49, without saying 49. What's root 7 times root 7? 7, right? Because 7 times 7 is 49, and the square root of 49 is 7. But we're going to try to not use the multiplying piece. That there is your answer. Oh!
Wait, can I simplify that?
I was going to ask that next. Can I reduce the 7s here?
No. Wait a second, I have a question. How come it's not 14, root 14 over 7?
Okay, I just explained it. Did you guys hear when I explained why it's not 14? If this was a radical, then yes, that would be root 14. But since it's not a radical, the only thing we can do is 2 root 7. Now, the question was, can I reduce the 7s? Perfect. Did you guys hear her? Can you repeat it one more time a little louder? You said no because? One's in the radical and the other's not. One's in the radical and the other's not. Good job. Same reason I couldn't multiply these together earlier and get root 14. All right, let's try another one. Number 13. 2 over 6 root 2. All right, a few things that kids mess up on here. First, can I reduce these 2's here? No, you cannot. Why? Because this is a radical, this is not. The same reason she gave earlier. Could I reduce the 2 and the 6?
Yeah.
Yes. Why? Because neither one of those are in radicals. But I'm going to pause. Do you want to reduce the 2 and the 6 now, or do you want to reduce it later? It's totally, what would you do if you were doing this problem?
No.
Reduce it now? All right. Again, why not these 2? One's in a radical, one is not. So could I do these 2?
Yeah.
This 2, what did we divide both of the numbers by? 2. 2 divided by 2 is 1, and 6 divided by 2 is 3. So I'm left with 1 in the numerator, and 6 root 2 becomes 3 root 2. All right, we're still not done, but we've at least simplified just a smidge. Do you guys see what we've done? Okay, who can raise their hand and tell me why this would be wrong if I left it? Raise a hand and tell me why this would be wrong. Yes. Because there is a radical in the denominator. So what's the process called? Starts with an R? Rationalizing. So we're going to rationalize. All right, so we multiply. Now here's another place kids mess up. Oh, I'm going to multiply by 3 root 2. What's the problem here, the 3 or the root 2? Just the root 2. So all I need is a root 2. If you did 3 root 2 over 3 root 2, would you get a wrong answer? No, because 3 root 2 over 3 root 2 is still 1. You just end up with more to reduce at the end. Everybody hear that? Okay. It's okay to do 3 root 2 over 3 root 2, but it's not necessary. Root 2 over root 2 is enough. Why? Because root 2 is the only problem we have down here, not the 3. All right. So here's the tricky part. What's 1 times root 2? Root 2. If this was a 3 times root 2, would it be root 6 or 3 root 2? Okay, if this was a 3, that would be 3 root 2. Do you guys see that? All right, now here's the tricky part. 3 stays 3 times, without saying 4, without using 4, what's root 2 times root 2?
Root 4. It's 2.
Which is 2.
2.
Right? Do you guys agree? Because it is a pair. Do you guys see that? The reason I want you to get used to that is because if this was like we had earlier, 63 and 63 or 53 and 53, don't multiply them together. Just see them as a pair. 7, pair, 5. Where are we at? Pair, 2. The only extra step is what do I have to do with that 3 and the 2? And since neither one of them are in radicals, is it okay to multiply them together? Yes, so it's root 2 over what? 6. Can I reduce the 2 and the 6?
No.
No, why not?
Because one has the thing on the top.
One has a thing on the top. One's in a radical and one is not. Does that make sense? That is it.